Hey everyone and welcome back. So in the last video we have seen what is upper bound and what is lower bound. So today we are going to solve a problem which is search insert position, which is also a easy problem. So in this problem you have given an array and also a target value. Okay, now you have to return an index where this value available in the array. So our target is available at the index of 2, so our answer will be 2 for this example. Now let's take another example. Let's say we have target equals to 2. Now this time we don't have a target in this array, so now you have to return an index where it will be inserted in the array. So let's say if you insert this target, the array become like this, right? So the index at which it is inserted, you have to return the index, so it will be 1. So the question is, first you have to try to find the value in the array. If it is available, return the index. If it is not available, you have to insert the value and return the index. One more thing, our array is sorted. Okay, so if you insert a value, it should be sorted, not at the end. So let's see how we can solve this problem. So we have 1 3 5 6 and you have target equals to 2. If you insert this value, then our new array will become like this and the index number of this is 1, right? So from this you can directly see, you can create new array, right, and insert a value 2 and then sort the value. So create new vector, right, because it is dynamic. Insert target then sort. So to solve this problem we have to follow these 3 steps. So let's create a vector which will be my answer vector. Okay, now let's insert all the values from the nums to the answer vector. After pushing all the values from the array to the answer vector, we will also insert target to the answer vector, right? So initially we have array 1 3 5 6, then we inserted a target value which is 2, so push back adds the value at the end. Now we got this array. Now after this we will sort this array. After sorting this array, so our array will become 1 2 3 5 6, right? Now we have to find the index. So to find the index we can use linear search. So for linear search we will write a loop again. Now this time we will be taking the size of the answer, right? Because initially it was n for the original array. After adding one element it will become n plus 1, or you can take size of the answer and try to find the target. If it is available, just return your index of that target. So in this way we will be able to solve our problem. Now what is the time complexity? So this is taking n because it is running for n times. This is taking n, which is our space, right, because we are using extra space. It is taking n log n for sorting. Here again it is taking n. So if you look at it, your overall time complexity is 2n plus n log n, right? And the space complexity is n, right? Because in this problem you have to have extra vector and you have to sort that vector, so your target will be available at the certain index. Now the time complexity is n plus n log n, but the question asks us to solve this problem in the time complexity of only log n. That means we cannot sort our array or we cannot create another array. So you have to solve the problem in the log n time complexity. So let's see how we can solve this. So let's write our array again here, and we have target initially 5. Now you have to find an index, right, and it is in the ascending order, so that 5 will also be inserted in the ascending order. So we have 5 here already available, so we just have to return the index here, right? Let's say if you have target equals to 2. Now you know that it is in ascending order, if you insert your 2, it will be placed somewhere here and the indexes for this value will be shifted, right? So if you look at it, you have to find smallest index which is greater than equals to the target, right? Because in the first example 5 is available and we have to return the index, so it will return the smallest index if we had a multiple values, but in this problem we will be having only unique values. Okay, now if you look at this target 2 will be inserted at this position, means at the position of 3, and 3 will be shifted to the right. So we can say we are inserting at the position where we have smallest index compared to this 3, right? We can use lower bound because lower bound points you to the smallest index such that its value is greater than equals to the target. So for this case we have 3 which is greater than target, because equal is not possible, so it will look for the greater value and it will replace the greater value, means it will replace the 3 or shift the 3 to the right, so 2 can be inserted at this position. So we can say this index is our index where our target will be inserted. So in this solution we are not actually inserting our value or trying to manipulate our array, we just want to find the index. So we want to search the element as well as we want to find the index, so we can use lower bound which is based on the binary search. So for this we can write our lower bound code. Okay, so let's directly write our code. You will be able to understand. You just have to understand this, that if you insert this 2 here, your 3 index will update to the 2, so the 1 index will be assigned to the target 2, right? And the lower bound finds the smallest index, so first it will try to find equals value. If it is not available, it will find greater value. So in this case we have greater value 3, so 3 will be shifted to the right and 2 can be inserted here, so our index or answer will be 1. So you have to solve this problem in the log n time complexity. Okay, so in this case we have target 5. If you find a lower bound, you will be able to return this index because it will look for the greater than equals to. Here we have target 2 is not available, so the greater value to the 2 is 3, so 3 will be shifted to the right, so we can insert our 2 at this position. Similarly in this example we have target 7, so target 7 cannot be inserted here, so we will be insert this target at the nth position which is 4, right? And all the values are distinct and in ascending order. So let's first declare the size of array, right? Then let's declare low equals to the 0, int high equals to n minus 1 and answer equals to n, right? After this, while low less than equals to high, we will find mid low plus high by 2. If nums of mid is greater than equals to target, then we can take this as one of the answer and we need a smallest index, so we will move to the left, else we will move to the right. Here we will return our answer. So our initial test cases got passed. Here you can see our code got accepted. Okay, so the time complexity is log n because we are using binary search and the lower bound. So if you weren't able to understand lower bound, please go back and watch previous video. In that video I explained what is lower bound and upper bound. Okay, so this is our solution for this problem. So that's it for today. Until then, thank you everyone. Have a nice day.